Together with me, we have our colleagues, Arianna Dell'Olio and Matteo Masotti, part of the research group in the Department of Agricultural Science and Technologies at the University of Bologna. And today we want to present you the ENFASYS web tool that is our, let's say, final goal in the project, and let's say a summary of many other activities that we and the other colleagues and partners in the project delivered during the last 4 years. So we are really happy and pleasure to present it today, not tomorrow. Please, Arianna, next slide. Yes, please.
Okay, thank you. So thank you, Filippo, for this brief introduction. So as Filippo already mentioned, this is the result of a lot of years actually of work. But we wanted to start from the beginning and just give a few references into the modeling framework that we employed for the development, let's say for doing the background work that you will after see in the web tool. So you will see it in its final form and in its most accessible form, but we wanted to give you a few theoretical and methodological references before moving to that part. So as you can see, we already did introduction and framing. We will do the modeling framework now, and then get an overview of the scenario development of the policy bundles, and then have a little demonstration and a space for a Q&A session. So just to give you an overview of today's agenda. Well, you already know that we are the speakers, so starting from why we thought that it was useful to employ a dynamic approach for the type of analysis that we have conducted in the ENFASYS project. So to analyze agri-food systems. A dynamic approach was deemed by the team of Unibo particularly fitting because agri-food systems are complex systems. So they are characterized by interdependencies, non-linearity, and delayed effects. So some impacts can show up over time as well. And for this reason, we try to approach a system dynamic methodology. And what do we mean by that? From a theoretical point of view, what we mean and actually what the theory and the state of the art proposed to us is system dynamics as a perspective and a set of conceptual tools to understand the structure and dynamics of complex systems, which in particular we employed in terms of moving forward from static representations, because of course, systems thinking in general is a broader discipline that is characterized by many different specific methodological approaches. But we found that employing static representations would present some limitations. For instance, an example of static representation, which is obviously are very complex and beneficial methodologies. An example can be systems mapping, for example. But in those cases, distinguishing between the structure of the system and the behavior of the system, so how does the system change over time, and how do the variables that characterize a system change over time, is more difficult because static representations, such as, for example, system mapping, do not entail, do not offer, let's say, to the user to the researcher that employs them, at least a standardized way of assessing change over time. So this is really what we wanted to get into when we chose a system dynamics approach. Of course, nevertheless, every system dynamic representation starts from the assessment of the system structure at the base of the process. So, for example, you can see here that our process started with the structure, so with the creation of causal loop diagrams. I assume at least some of you are familiar with this terminology, but we can consider them systems, complex systems, static maps for our understanding today. And the following step that we undertook as a team is the quantification of the causal relationships between variables. So this is what allowed us, as you can see, to move forward to assess the system behavior over time. Because the dynamics of the system and how the system behaves emerge when the system structure are quantified. So in particular, how does change propagate through the system? Well, the influences between the variables interact with each other. Processes emerge that shape the change of the system. And most importantly, as we already mentioned, time dynamics are crucial and can be evaluated employing these type of methodologies. For example, in the form of delays or accumulation. So this is really what we wanted to get a look at when we chose this type of method. And then what does drive the system behavior? Because of course, agri-food systems are very complex, and the behavior of agri-food systems is shaped both by structural factors, such as, for example, economic conditions or market structures, and behavioral factors, so perceptions, social norms, or cultural dynamics. So in order to evaluate the interaction and influence between these two, let's say, types of factors, employing a complex system dynamics approach seemed the most beneficial. And moving on to ENFASYS example more specifically. So our final output after our activities carried out in the course of the project is 3 system dynamic models that are associated each, as you can see here, with a strategic transition pathway. So one more related to agriculture, so low input agriculture, one more related to livestock systems, and one more on direct selling and consumption models. And these were developed employing the software Vensim, as you can see here. So this is our, let's say, final output that the web tool that we show you today is based on. And just to have a very brief overview of which variables did we include in these models, and so what can we have a look at using the web tool and using the models. For example, we included policy and governance support. So this should be intended in terms of sustainable transition. So we can think of it, we have a more complex definition, of course, but we can think of it as the extent to which farmers are supported in the sustainable transition, for example. And for each of these variables, we have a so-called baseline level, so a starting point that we retrieved from the literature, and then we can assess the change of all of these variables to simulations. Or, for example, you can also see farmers' motivation, so how motivated are farmers in undertaking sustainable practices, their perceived economic viability, their access to knowledge and expertise resources, and most importantly, which is our so-called central variable, so what we also use to make the more complex analysis, is the sustainable agriculture adoption rate, because this is ultimately a bit of the goal of the ENFASYS project more in general, to overcome the lock-ins that hinder the sustainable transition, in particular, that hinder the propagation of the adoption of sustainable sustainable agricultural practices. We focused a lot on this. So just to summarize, finally, as we already mentioned, we have three ENFASYS behavioral system dynamic models. All the models have their initial values that are retrieved from the literature and that are the starting point. And all the variables in the models are connected through causal relationships, which are quantified, as we said. And this structure allowed us to run simulations showing the systemic outcomes and enabling the creation of scenarios, which Filippo will illustrate shortly. And so just to summarize this first part, we wanted to try to condense in one sentence what the ENFASYS system dynamic models allowed us to do. And it is to answer to this question. So what could the future of selected variables in the EU farming systems look like over the three strategic pathways that we already introduced over the course of the next 10 years, because obviously in the definition of the system boundaries and in the definition of the boundaries of what we were going to represent, there is also the time horizon, which is 10 years. And obviously the set of variables that we analyze is finite, is not infinite, unfortunately. So this is a bit of the synthesis of what the web tool enables us to do. And I pass the floor to Filippo for this following section.
Thank you, Arianna. So, as Arianna well explained, our, let's say, theoretical foundation and also our basis for the web tool that is derived from the work on system dynamic models that we developed in ENFASYS project. Then, as also here, Arianna will explain, system dynamic models are quite a complex way to visualize the system and visualize the transition through time, so through a time horizon. Then we needed also as a project to present the outputs in a more accessible way for a broader public, not only for researchers. So that's the answer to the question, why a web tool? Because we want to represent the output of the system dynamic models and also the exploration of policy scenarios for sustainable farming transition. Because in the end, a big aim also for us and for the project was and is to support policymakers and stakeholders in exploring possible impacts of the strategies, but also show how both the dimension we implemented in the models and then also in the policy scenarios, so the systemic and the behavioral one, how these actions found in ENFASYS project can interact and change the system dynamics. Moving from a static recommendation, as many policy recommendations are, to scenario-based decision support, and in the end, make complex system dynamic models output more usable for all the stakeholders. Next slide, please. So just to give you an overview about how we arrived to the policy scenarios, so how we developed the policy scenarios, we started from different deliverables of the project, in particular these three that you may see here in the slide, and we ran a text analysis on all the results and discussion section of the deliverables to find recommended interventions that are, let's say, single intervention that need to be then aggregated to create a bigger policy, to create bigger policy bundle. Then with the text that we derived from the deliverables, were coded by assigning each to a domain of intervention that come from the literature also here. So we create these three big domains that are the economic interventions, knowledge-based intervention, and policy and governance-based intervention, and then 7 subdomain. And then each of the let's say micro-intervention that we found in the deliverables were assigned to these subdomain. As you can see here, financial incentives price reduction, just to provide you an example, is let's say a sum of 3 different micro-intervention that you can see here. We also changed and stated which are the target, so consumers, farmers, policymakers, and so on, and then assign all to a domain that in this case is market-based. In the end, at this point, we identified 32 interventions, but the pathway to arrive to the scenario, to the policy bundle, sorry, is not ended. Then we thank you. We draw another textual analysis on all the intervention, the micro-intervention, and then also the description that we create, aggregating the different micro-intervention for the middle step. Also here, with the aim to aggregate and connect different intervention, leading to the identification of 7 macro intervention, 7 policy bundle. Then we tested, sorry. Okay. In the models. Next slide. Sorry. These are our 7 policy bundles that again are come from the deliverables, so come from the results of the project, so are more or less inductive, and can cover the different domain and also aggregate the different domain. Because an important point here is that for the models, for the system, also in general, a single direct intervention on a single domain, on a single part of the system can't create a big difference, a big change in the system. So we merge and create policy bundles also on this statement. As you can see here, the archetype, no, please, thanks, are covering the different parts, so starting from the affordable purchasing, focus on the consumers, and the labeling and price reduction, then the alignment among the value chain actors. Another one was mainly focused on the implementation for the transition, so direct to the farmer, giving them the economic viability to do that, and the knowledge, and all the other archetype and policy bundles, so cover the different part of the system. So next slide. Then now we had a set of interventions that needs to be integrated and assessed in the model. So how we, let's say, change the narrative policy bundle in a quantitative policy bundle, changing the, let's say, the multiplier, changing the, yeah, I see in the in the chat, yeah, for sure. So apply all the bounded multipliers, select, so what we did, selected links were strengthened or weakened based on the intervention narrative using the multipliers, constrained between 0.75 and 1.25 to ensure the reliability of this intervention. So trying to represent the reality also here. An intervention can change totally a system, but can create at the first glance a change, and then can be reiterated through the system and create a bigger change. So we simulate the intervention bundle. So each intervention was tested as a scenario within the pathway model for a comparison on how different intervention logic can affect the transition dynamics. And then we evaluate the results, so the scenario output, comparing through two metrics, so the impact of the transition of the policy bundle and the resilience of the policy bundle to assess the magnitude and the robustness of the simulated transition. Next slide. So to give you just also here an overview about the metrics used in the web tool, we had the impact and the resilience. So all the three ENFASYS pathways produce different simulation output based on the pathway-specific variables and the transition dynamics embedded in the model and embedded in the system. So we need to compare them, the three different models. We can compare them directly on also, even if we use the same policy bundle, the transition dynamics and the system dynamic embedded in the models and in the system are totally different. So we need a middle step metric that can evaluate the different performance. These are the impact and the resilience, as you can see here. So the impact captures the overall magnitude of the change, and the resilience, the robustness of this transition trajectory. So assessing whether change is stable and consistent over time. Thank you. And now I pass again the floor to Arianna that will show our great web tool.
Thank you. I will stop sharing my screen for a second to open correctly the window of the web tool, and I will be back in a second. Okay. Okay. So we are here on the, I think you see it. So this is the home page of the web tool that can be accessed in case you were wondering. Well, there is the link in the slides that we will share later, but normally it is also linked to the broader ENFASYS website, ENFASYS website, because of course ENFASYS, as any Horizon Europe project, has their own visual identity, website, and resources, and this is a subdomain of the website. So just to give you a coordinate of where we are in space and time. So for example, if I clicked here, I would be redirected again to the initial to the main project website. And this is the first page that users find themselves into when they access the Scenario Explorer. So here is a very short explanation, and as you can see, coherently with what we illustrated previously, one can find immediately the different pathways that can be accessed and explored more in depth. So I will finish illustrating the homepage, and then I will go more in detail on one of the pathways that we are that we want to show to you today. So this is the first way that users can move into the web tool. But we also wanted to include from the start the description of all the different intervention bundles that also Filippo already illustrated, but in order for the tool to be self-standing, we thought to include their characterization and main ratio already in the home page. And from this button below the Intervention Bundle Explorer, another section that I will show in a minute is possible to be it is possible to access another section, which is the bundle comparison. So what Philip already mentioned, so the comparison between the performance of the different bundles in terms of impact and resilience. We will go in detail in a minute. And just to finish the overview of the homepage, at the bottom of the page, we have a section, a methodological section, so that if the user clicks here, they are redirected to the methodological section, a glossary that we thought was very important, and I will show you very quickly. We included several so-called general definitions in terms of being related to system dynamics, system thinking, the ENFASYS project. So more in general to help ease the users into the use of the tool. And then more specifically, we have included the list of variables. Some we have already seen in the slides before. Thank you, I saw the message. Some we have already seen before, and we included here, separated into subsections, which variables we have for each single pathway. So for each single system dynamic model that was produced in the context of the project and that is accessible here. So I go back to the home page, and as an example, today we thought of showing you the low input agriculture pathway. So for instance, as you can see here, this pathway focuses on reducing synthetic inputs, such as fertilizers and pesticides, while improving soil health and biodiversity. So by clicking on the Explore button, we are redirected to the Pathway 1 page. And with this menu, we can select any of the intervention bundles applied to the low input agriculture pathway. Today we thought of showing you the 7th, so policy alignment and orchestration. If you notice, once it is selected, you already see the trajectory here. The trajectory that you see here is the trajectory of the so-called central variable, so sustainable agriculture adoption rate. And as you can see, coherently with what we showed earlier, the time horizon on which it is showed is 10 years, so 2025, 2035 in this case. And you can explore it further by clicking on this. And in doing so, the user lands on the single bundle applied to one pathway page. So this is pathway 1, bundle 7. And you can see here a small description. And here you can see the analysis that we have performed and that it is accessible here. You can see, as it is shown here, the trajectory of the central variable, so the trajectory of the adoption rate. And you can see in this case the comparison between the baseline model, so the simulation that we run before putting the intervention of policy alignment and orchestration in here. The baseline is the one composed by dots, whereas the orange line is the behavior of the central variable after the intervention is inserted into the model. As you can see, the distance is not much, but this is good because it makes us understand that the result is very plausible, because of course, if we had crazy curves that could have easily meant that the model was not super well calibrated, or that something was maybe less refined. And as you can see, one can access the an analysis. This is what happens when I move my cursor over the activation phase. As you can notice, we have divided into 3 phases, and for each phase we can access a description of what happens in the activation phase, for example, and then an assessment in percentage levels of what other systemic variables contribute in that phase to the growth of the central variable. So in this case, we know that in the activation phase, the sustainable agriculture adoption rate is mainly supported by environmental awareness initiatives, secondly by knowledge and expertise initiatives, and then going, let's say, more to the bottom of the screen, you can see the others. And it is also very interesting because you can assess, going from one phase to the other, if the most supporting variables do change place, or whether the same one remains the most the one that has the most impact or not. And you can also assess how distributed the impact is of each variable. So because I mean, as it is shown here, it is more evenly distributed or less depending on the phase. And the other resource that we see here is the assessment in terms of resilience and impact of this specific intervention bundle in this specific pathway. So in this case, we can see that resilience and impact both perform on the low side of the spectrum. This is an assessment that we perform in terms of low, mid, and high. So it is quite straightforward. To the bottom of the page, one can also find a section of interpretation of the results and policy impact of what is shown in numbers. But going back to this concept, I now want to show you, and going back to the homepage to access it, the feature of Explore the Bundle comparison. So I clicked on it by the homepage again, and as you can see here, this matrix puts all the bundles in comparison. As you can see, they are color coded. So moving my cursor on low input agriculture, only the bundle of intervention implemented in the low input agriculture stand out, then livestock, etc. And they are all distributed over this matrix to assess, to cross-assess, let's say, their performance in terms of these two metrics. If we move the cursor on the matrix as well, we get a little analysis on the intervention bundle, for instance, one, and how it performs across pathways. So this was very important to us. This was a very important result for us to reach because it meant that after, let's say, all the building blocks that we have created, so first the pathways, then the intervention bundles, then the single intervention bundles for each pathways, we managed to arrive to a point where they can be compared and some conclusions can be made and some policy advisory can be taken from the comparison of the bundles across pathways. So this is all from my side, and I will now open the floor to questions. With Filippo, we are open to answer to you because the let's say the frontal part and what we wanted to show initially we covered all. So thank you for listening as well. We can also put, I will put the link of the web tool in the chat in case anyone wants to play with it. It is in the final refinement stages, so some parts of the text might still be missing, but it is here.
Thank you, Arianna. Thank you, Uniba team. If there are no questions for the presenters, I will thank you all for your time, and you will find the this webinar on the ENFASYS website until Friday, the latest. There will be also slides available, and until then you will find the ENFASYS website link in the chat. If you think of any additional questions, congrats are in order as well. Good to hear it. You can always send us an email on info, and I'll make sure to forward your question to the right person. Thank you all. Thank you, Uniba team.
Thank you. Thank you again. Bye.
Goodbye.
Thank you.
Bye bye. Thank you.